Now, here if we make a plot between annual cost and order quantity, right, then this line is showing the carrying cost which increases with the increase in order quantity, and this line is showing ordering cost which decreases with increase in order quantity. These two costs intersect at point A, and the summation of these two costs gives us the value of total cost, right? This line is showing the value of total cost. What we see that the value of total cost is minimum at this point, right? And right, quantity corresponding to this cost is our economic order quantity, right? We study inventory cost only for this purpose, because we want to purchase such a quantity for which total cost of keeping inventory or total cost for ordering them is minimum, right? Now, order quantity, so we can see that economic order quantity is that order quantity which will minimize the total variable cost of managing the inventory, right? Now we will discuss a method for the calculation of economic order quantity, right? Here we make a plot of order quantity along with the time, right? This line is showing our average inventory. This is total our order quantity Q. Average inventory is Q by 2. This point is reorder point, right? This is our maximum quantity line, right? And this one is being our minimum quantity line. Below this there is the safety stock, right? So we have started with minimum inventory to maximum inventory line, right? Now, let S is annual consumption of the product, CO cost of placing an order, right? CO unit purchase cost of an item, and I is interest rate charged per unit per year, and Q is our order quantity in units, right? Then the total variable cost of managing the inventory per year will be equal to the annual ordering cost plus annual cost of carrying the inventory, right? Now, what we see that if total cost of managing the inventory per year is denoted by E, then E will be equal to CO into S upon Q, that is the annual ordering cost per year, and CUI into Q by 2, that is annual cost of carrying the inventory, right? And this is the explanation of this expression right here. CO is denoting the cost of placing an order, and S by Q is basically number of order per year. In the same way, Q by 2 is average inventory, and CO into I is inventory carrying cost. Clear? Now, we know that, right, to have economic order quantity to a minimum value, right, the total cost of, right, for having economic order quantity, the total variable cost of managing the inventory per year should be minimum, right? So now this expression must be differentiated one time and it should be equal to 0. This is the principle of maxima or minima, right? So for E to be minimum, d upon dq will be equal to 0. Differentiate it. When we will differentiate, what we are finding the ordered quantity q is equal to under root 2co into s upon cu into y, right? This is the required, and this ordered quantity is known as economic ordered quantity. Why? Because total cost of carrying the inventory is minimum, right, for this value, and that is the required expression for economic ordered quantity, right? So do remember, EOQ is equal to 2COS upon CUI, right, whole to the power 1 by 2, where S is annual consumption of the product and I is interest rate charged per unit per year. CO and CU are the costs, right? CO is the cost of placing an order and CU is unit purchase cost of an item. Right? Now we will calculate optimum lot size from the same expression, right? Optimum lot size is basically if the item is being manufactured, then it is necessary to determine the optimum lot size, that is the lot produced in one step, right? When we are manufacturing any item, then we have to calculate optimum lot size. So we follow same method for the calculation of optimum lot size, right? The expression will come out as Q not equal to 2COS upon COI. Here CO is denoting the setup cost per production run, S is here annual production, CO is unit purchase cost, right? And N is number of production runs per year. Sometimes expressions are made for the calculation of optimum number of production runs, because when we calculate or derive expression for this one, then this number is involved, right? But when we summing or finding the expression this, then they are cancelled out meanwhile in the step, right? So N naught is optimum number of production run, right? And this is equal to SCU into Y under root 2CU. So these are the objective of this inventory cost, right? We have to estimate economic order quantity and optimum lot size, right? The expressions are same, but during the calculation we have the same units, same letters have different meaning. When we are dealing optimum lot size, then S will be annual production, CO will be setup cost per production run, CU will be unit purchase cost, and I will be interest rate. But when we are keeping the inventory, talking about inventory, then CO will be order cost of placing an order, CU will be purchase cost of an item, and S will be annual consumption of the product. So this is all about economic order quantity.